So good morning. I'm Kiran Kumar. We work in the Department of IUC. So I'll be handling the subject design and analysis of algorithm. Okay. So the topics to be covered today: Euclid's GCD and algorithmic problem solving and study of asymptotic notation. So I was telling that there is a theta, there is an O, there is an omega. So we'll be seeing what do you mean by that. Okay. So there are many methods of finding the GCD, where you have come across a primary school method, a secondary school method, that is what you have studied in your PU, and any university, that is in your plus two, or any other university. Okay, where here you are knowing so how to find out the GCD of a number. Here in secondary school, where you will be finding out the prime factors, that is in your middle school or in your high school. This is with respect to your university. Okay, now what is a Euclid's algorithm? So here you need to find a GCD of m comma n. Okay, here you're going to find out a GCD of m comma n. How we are going to find out? So it's a recursive call. Okay, it's a recursive call. Okay, GCD of m comma n. Okay, so how we are going to find out? If the GCD of m comma n, that is GCD of m comma m percentage n. So using that particular formula here, you're going to find out the GCD. So here Euclid's algorithm is GCD of m comma n equals GCD of n comma m mod n. Okay. So till when you're going to find out? Till the second number is 0. Okay, which makes the problem trivial. Okay. Next, there are two descriptions of an Euclid's algorithm. That is, when n equals 0, then you're going to return m. That is m mod n. Okay. If the value of n is 0, then you're going to just return the m number. Next, in step 2, you're going to divide m by n, and what value you're going to get, you're going to assign that to r. Next, you're going to assign the value n to m and value r to m, and then again you're going to move to a step 1. Okay, and then you're going to return that particular number. Next, what is the other method? That is integer checking algorithm, where you're going to assign the value, that is the minimum value, to t. Then you're going to divide that t by m. If the remainder is 0, go to step 3, where you're going to divide n by t. If the remainder is 0, return t and stop. Else go to where we go on decreasing the values. Okay, after decreasing the values, again we'll move to a step 1. Again, if a remainder is 0, we will move to a step 3. Again divide. Again, in that case, if it's not 0, again you go to step 4, decrease t by 1. Okay. Next, other methods, the middle school procedure, prime factor of m, prime factor of n. Find all the common prime factor, and then you're going to find out. Is this an algorithm? No, this is not an algorithm. This is just a step for finding out the problem. That is finding out the GCD. Next, this is nothing but a sieve of erythronesis. Okay, where here you need to find out all the prime numbers from the value 2 to 20. That is given the value of n as 20, and here the value is 2. So here you need to find out all the prime numbers from 2 to 20. Okay, now p tends to 2 to n, do what you're going to do? A of p, you're going to make it as p. Next, for p tends to 2 to n, do if a of p not equal to 0, if p hasn't been previously eliminated from a list, you're going to find out j equals p star p. Now what is that a of p? Okay, if the value of a of p is not equal to 0, it contains some value, then what is the value of j? The value of j will be p star p. While j is less than or equal to n, do you're going to mark that j as eliminated, and then for that you're going to add j equals j plus p. So till when you're going to perform this particular operation, till where we reach 20. Okay. Next, there's a termination of an Euclid's algorithm. Okay, where here the second number, if the second number of the pair gets smaller in each and iteration, so and it cannot be negative. Okay, so and then a new value which is always smaller than n. Next, eventually r becomes 0 and the algorithm stops. Next, we move to a fundamentals. This is very important from exam point of view. Okay, where it's an algorithm, it's a procedural solutions to a problem. It's not an answer, but rather a specific instructions of getting the answer. Okay, so you require steps in designing and analyzing an algorithm. So this is the algorithm design and analysis, where first you're going to understand the problem. After understanding the problem, you're going to decide on, so for this, whether a particular problem should be solved parallelly or simultaneously, or if the problem will yield an exact solution or an approximate solution, which are all the data structures that we need, which algorithm design techniques which you'll be studying in from module 2, 3, 4, 5. Okay, and then after that you're going to design an algorithm, and then you're going to prove the correctness of the algorithm, and then you're going to analyze, and then finally you're going to code. Okay, so here you can see decide on the computational means, exact versus approximate problem solving, data structure, algorithmic design technique. Now prove the correctness. So if there is some problem here, it again goes back. Okay, and then analyzing the algorithm, if you want to slightly modify, then again you should go back and you should decide on the computational means, exact versus approximate solving, and you're going to select the different algorithmic design technique. Okay, next understand the problem. So the problem should be given precisely, should be told what to do. Okay, what is the problem? Okay, first is understanding the problem. What should be the input? Okay, what should be the input? What are the range of the input that an algorithm will handle? Next, failing which, what happens? Okay, step 2, computational device, whether you're going to use the sequential algorithms or you're going to use the parallel algorithm for execution. Next, whether the problem which you're going to solve needs an exact solution or an approximate solution. Okay, that is the problem that cannot be solved exactly, because finding the square root you're going to get in some points. Okay, whereas in terms of traveling salesman problem, so you're going to get an exact solution, but it takes time. Okay, next, decide on the appropriate data structure. So whether you want which data structure, whether, say for an example, in DFS and BFS we'll be using a data structure called as stacks and queues. Already you have studied DFS and BFS in your data structures. Okay, then algorithm design technique, there are many design technique. From module 2 you're going to study variety of design techniques, say divide and conquer, greedy algorithm, dynamic programming, branch and bound, backtracking. Okay, so that all you're going to study. Out of that you have to choose any one. Next, methods of specifying an algorithm, whether you're going to write a pseudocode or whether you're going to write the flow chart. Okay, next you're going to prove the correctness. So for the input, okay, for n number of input you're going to get a required output. Okay, next you're going to analyze the algorithm. How you're going to analyze? You're going to find out the time efficiency, you're going to find out what is the space required, and how can you simplify your algorithm without recursion or with substitution or using any other method. Okay, next you're going to code the algorithm. Next is nothing but an asymptotic notation. So I told you there is an asymptotic notation, that is O, omega, theta. Next, what do you mean by O? O, usually we go for a worst case, theta we go for an average case, omega we go for a best case. Okay, so O notation. So there is said to be a function is said to be O of g of n. Okay, denoted by t of n belongs to some function O g of n is bounded above. Since it is a O is a worst case, so we are going to give an upper bound on this value. Okay, with a constant multiple. there exists a positive constant and the non-negative integer n naught. So f of n is less than or equal to c into g of n for every n greater or equal to n naught. Okay, so this gives there is some function. Okay, there is some function. Sorry. Big O. Okay, say this is a function t of n. For this, there is a O g of n. That is, you have given an upper bound. Whereas in terms of an omega, so you're going to give the lower bound. You're going to give the lower bound. Okay, since it is used for a best case. Next, for theta, the function comes somewhere over here where you're going to give the upper bound and you're going to give the lower bound. Okay, and this is the bibliography which we are referring. Okay, students, so thank you.